Alrighty, so here's part 2 of the vocab for formative 1. Again, a lot of words here. Well, this one's not so many words, but you got to learn them. You got to spend time with them. You got to study them. You got to know them. This one's a pretty simple word. It's transversal. So say it again. Transversal. A line that intersects two or more lines in a plane at different points. Please note the lines may or may not be parallel. So here are the two lines. This one cuts them. This T here is the transversal that cuts them. Now when it gets really cool is if I have two parallel lines, like C and D are parallel, and then T cuts them. We get all kinds of equality stuff that happens and all kinds of rules that we gain from it. If they're not parallel, we get nothing out of the deal. But again, notice remember the little parallel line or the parallel line arrows. So C and D are parallel. T is the transversal, and we get all kinds of cool stuff that happens because of that. And that cool stuff is what I'm going to cover in this section. Now, for this part to be useful, I have to say that these two lines, notice we have the red arrows here, are parallel. Remember, this is the transversal. Corresponding angles, that means angles that are in the same position. So angles formed by two lines intersected by a transversal. When the two lines are parallel, the angles are congruent. Now again, this definition here is corresponding angles. Notice I color-coded it. Angle 2 and angle 6. Notice they're in the same position. They're both in the upper right of each set. They are equal. Angle 1 and angle 5 are equal. Notice they're in the same position. So you might want to get colored pencils out so you can draw this picture. Angle 4 and angle 8, again, are corresponding angles. They are in the same position. They correspond to each other. It's not a terribly creative name. Angle 3 and angle 7, again, are corresponding angles. So 1 equals 5, 2 equals 6, 4 equals 8, 3 equals 7. Again, this only works when the transversal cuts two parallel lines. Now this word is alternate angles. Now alternate does not mean equal. It just means angles that are on different sides of the transversal. So again, here's my transversal. Here's my two parallel lines. So all these angles over here are alternate of the angles over here. So they're alternate on opposite sides of the transversal. It makes them alternate. It has nothing to do with being equal. The interior angles, so here we have our transversal again. And these are again two parallel lines. The interior angles are all the angles that are here, right, on the inside. So they're the inside angles. Now, nothing to do with equality yet. We'll talk about that in a little bit. But currently they are just the interior angles, the ones on the inside, between the parallel lines on the transversal. Exterior angles are angles that are on the outsides of the parallel lines. So here's our two parallels. Here's our transversal. All the angles out here and the angles out here are called exterior, angles outside the lines. Again, draw this picture. This currently doesn't tell us anything about equality until we do a couple more things. Okay, so now we have alternate exterior. So we combine the words alternate and exterior. So the lines that are, the angles that are on opposite sides of the transversal and on the outside of the parallel lines, like 1 and 8, are equal. 2 and 7 are equal to each other. Notice how they look alike too. That kind of helps as a guide. So 1 equals 8 because they are alternate exterior. So if I asked you, literally, and I will ask this on a quiz and test, why are 1 and 8 equal? How do you know? You could say they are alternate exterior angles. Again, that only works when I have the two parallels cut by the transversal. If I said why are 2 and 7 equal, you would say they are alternate exterior angles. And you do have to be able to tell me that. Alrighty, alternate interior angles. So notice, transversal, two parallel lines. The ones that are on the opposite sides of the transversal but on the inside are equal. And notice again I color-coded them. 3 and 6 are equal. And if I ask you how do you know that, you have to say alternate interior angles. 4 and 5 are equal. I would say how do you know that? You would say alternate interior angles. Now this one here, I'm going to use this later on a quiz just for the fun of it. Just wanted you to get a chance to see it. We can do the 4-by thing. Now I can't go from 1 to 16, right? If I had two sets of parallels, which I don't in this one, I can't go from 1 to 16, but I can work my way around, and we'll discuss that later. But I wanted you to see this. So two parallels cut by two different transversals. The transversals themselves are not parallel, but I can say things like, well, I can say that 1 and 14 are equal because they're alternate exterior. I can say that 6 and 9 are equal because they're alternate interior. I could also say that 1 and 6 are equal because they're vertical, right? And 6 and 9 are equal because they're alternate interior. That would make 1 and 9 equal. It gets kind of fun in my opinion. You could also say 1 and 9 are equal because they're corresponding. So there's lots of ways to do this.